everyone, very good evening. I welcome you all in India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, this is the last session of our 24 most important questions of computer organization and architecture for GATE 2024. We have already discussed 21 questions from different topics, that is machine instruction and addressing mode, ALU data path and control unit, instruction pipeline, memory organization. Now, this is a very small topic, interrupt driven IO and DMA. So from this particular topic, we are going to discuss three different types of questions which may be asked in the GATE exam. So let's move further. So this is brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. Following are the achievements and areas of expertise. This is my Telegram group. If you guys have any doubt related to your preparation, whether it is CS paper or DA paper, then you can post your doubt at this particular group. I'll be happy to answer. Okay, BYJU'S exam prep is going to conduct a national scholarship test on 29th of October, that is this Sunday, between 9 a.m. to 9 p.m. Do participate in this test and you may avail up to 90% off on the programs which are being offered by BYJU'S exam prep. Akhil, I have told you that from next week onwards, I'll definitely start that. Don't worry. Please keep patience. From next week, I'll start the classes for machine learning. Apart from that, on 1st of November, Abhinav Negi sir is going to conduct a workshop in that particular. So that particular workshop is for GATE 2025 aspirants. That in that particular workshop, sir is going to discuss a complete plan that how you can become a topper in GATE 2025 exam. So if you are aiming for good GATE 2025, then this workshop is for you. Apart from that, for GATE 2024 aspirants, the mega mock test series has been launched by BYJU'S exam prep tomorrow, that is on 28th of October at 12 p.m. You will eventually have the mock test for programming and data structure, algorithm and operating system. Do participate in the mock test on the regular basis. At least one mock test, you should appear for at least one mock test every week, so that you will be able to analyze yourself that how good you are managing your time when you are sitting in the examination hall. So that is the only key takeaway while you are appearing for the mock test, because this is very important. Those 3 hours while you are sitting in the examination hall will decide that what will you do in your career in terms of higher education, right? So that's the idea. So please, whether it is the scholarship test or it is the workshop or the mega mock test, for all you just need to download the BYJU'S exam prep app and you need to register yourself using your mobile number. So the link for the application is available in the description of this particular video. You can download the link, you can download the application using that particular link and just register yourself using your mobile number, and you will be able to participate in the workshop and mega mock test and scholarship test. Apart from that, the crash course is going on for GATE 2024 aspirants. If you are looking for a place where you can actually brush up all your knowledge before you finally appear in the examination, then this is the course for you. You can simply enroll for this particular course. If you want more details, then you can contact on this particular mobile number which is available at the bottom. Now, similarly, the courses are live for GATE 2025 and GATE 2026 aspirants also. So if you are interested in GATE 2025 and GATE 2026 course, then also simply connect over this number and you will get all the information that is required and you will be able to enroll for the courses. Okay guys, let's move with the very first question of this particular topic, that is interrupt driven IO and DMA. So this is a question which combines both the concepts, interrupt driven IO as well as DMA. So what happens in the interrupt driven IO? Whenever the IO device wants to perform any IO operation, an interrupt will be generated to the CPU. As soon as that interrupt is received by the CPU will complete the execution of current instruction that is being executed. After that, it will fetch the interrupt service routine corresponding to that particular interrupt and because of the execution of interrupt service routine of that particular interrupt will be serviced, and because it is an interrupt for IO operation, it means because of the execution of interrupt service routine, the IO operation will get completed. That's the logic. So please try to understand. A non-pipeline sequential processor, obviously, if nothing is given, I mean, this is just to confuse that non-pipeline sequential processor. By default, simply tell us that a processor. It's okay. By default, we assume that the processors are non-pipelined only, right? So there is no significance of this term in this particular question. So on a sequential processor, obviously processors will be sequential, all instructions will be executed one after another. A program segment, what a program segment is? A program segment which is a part of the interrupt service routine. So okay, these are part of the interrupt service routine is given to transfer. So this is a part of a segment which is given to transfer 500 bytes from an IO device to memory. So basically, if you are transferring 500 bytes from IO device to memory, then basically it's an IO operation. Basically, it is an IO operation. So this interrupt service routine is given for completing that IO operation. So this is your program, or basically this is your interrupt service routine. What will happen? Initialize the address register that from where you need to start transferring the data. Then finally initialize the count, because you actually need to transfer 500 bytes from IO device to memory. So this will be the starting memory address from where you need to store the data in the memory which you are receiving from the IO device. Initialize the count that you actually need to transfer 500 bytes. Now what will happen? Sir, load the very first byte from the device, store it into the memory at the address which is present in the address register. Then obviously if you have transferred 1 byte from the IO device to memory, then you will increment the address point, you will increment the address so that the next data can be stored at the next location. So increment the address register value, and at the same time, because you have transferred 1 byte of data, therefore the count value will decrement by 1. That is, the remaining data which needs to be transferred will be only 499 bytes. Now you will keep doing this if count is not equals to 0. If count is not equals to 0, then keep loading 1 byte from the device and store it into the memory. Load a byte from the device, store it into the memory. Load a byte from the device, store it into the memory until this count value becomes 0. So when count value becomes 0, means you have transferred all 500 bytes from the IO device to memory. So basically, in order to complete this IO operation, you need to execute this interrupt service routine. Because of execution of this interrupt service routine, IO operation will get completed. That's one aspect. This is with respect to IO driven, I would say interrupt driven IO, not IO driven. It is with respect to interrupt driven IO. Now same question, it is not a different question. I mean, the space is not sufficient, so this is whatever is available here is with respect to interrupt driven IO. Assume that each statement in the program which is given in the previous slide is equivalent to a machine instruction. What do I mean when it says a machine instruction? One machine instruction can be executed in 1 clock cycle, right? So when it says that is equivalent to one machine instruction which takes 1 clock cycle to execute, if it is a non-load store instruction. So if it is non-load store instruction, then it will take only 1 clock cycle. The load store instructions are, however, taking more number of cycles, that is 2 clock cycles. Yes, we can understand, because whenever load store instruction is involved, the memory access will be involved. Whenever load store instruction is there, memory access will be involved, and memory access is a slow operation, therefore it may take multiple number of cycles, right? So that's the idea, that the instructions which are non-load store instructions can be executed in 1 clock cycle, and the instructions which are with respect to load store will require 2 clock cycles. Now that's one aspect, sir. Okay, so you will initialize the address register. This is one instruction. So please try to understand, sir. Sir, look at this, sir. To initialize this address register, obviously this will be done only once, so 1 cycle will be required for initializing this address register. Sir, 1 cycle will be required for initializing this value of count. Please try to understand that this loop will execute for 500 times. This loop will execute 500 times, and within each loop you will load 1 byte from the device. So because it is a load instruction, obviously two clock cycles will be required. Store it into the memory, again 2 clock cycles will be required. Increment, it is a non-load store instruction, so for this particular instruction only 1 clock cycle will be required. Decrement is again a non-load store instruction, so 1 clock cycle will be required. For this comparison, 1 clock cycle will be required. So sir, how many? Sir, in one iteration of this loop, 7 clock cycles are required. In one iteration, 7 clock cycles are required, and there are 500 such iterations. There are 500 such iterations. So sir, 3500 cycles will be required for the execution of this loop, and this 2 cycles will be required for initializing these 2 registers, that is count and address register. So overall number of cycles. So if I ask you that what will be the number of cycles using interrupt driven IO, not very difficult, but just try to understand. The number of cycles using interrupt driven IO will be 3502. Okay sir, good enough. Okay, now the same thing. So please try to understand that what is being said, that the designer, whosoever is designing the processor, also has an alternate approach, can also use the concept of DMA controller to implement the same transfer. Can use the concept of DMA controller to implement the transfer. Obviously, DMA is also used to transfer the data directly from memory and IO device. So what is happening? The DMA controller requires initially, please try to understand, whenever you are using the DMA, you need to initialize the DMA controller. First, you will initialize the DMA controller, then DMA controller will send the signal to the IO devices to prepare the data. Once the data is prepared, then the IO device, then the DMA will transfer the data from IO device to memory based on the latency of the memory device. So please try to understand, the DMA controller requires 20 clock cycles for the initialization. So for the initialization of the DMA controller, you will require 20 clock cycles. It will be required only once. It will be required only once, and other overheads. So whatever, if other overheads are associated, then those overheads can also be completed within this 20 clock cycles. Now, each DMA transfer cycle takes 2 clock cycles to transfer 1 byte of data from device to the memory. So if you are using DMA, then DMA transfer, when you are actually performing the transfer operation, then DMA transfer cycle takes 2 clock cycle to transfer 1 byte of data from device to memory. How many bytes of data needs to be transferred? Sir, 500 bytes of data needs to be transferred. Each byte will require 2 bytes. So 500 into 2, that is 1000 bytes will be required for the transfer. So these are the transfer. Those many cycles will be required in this transfer. Apart from that, 20 cycles will be required for the initialization. Yes or no? Initialization of DMA controller, DMAC. Initialization of DMA controller. So how many total number of cycles will be required while you are using the DMA controller? Sir, when we are using the DMA, the total number of cycles required will be 1020. Yes sir, 1020. Now, what is being asked? Sir, the speed up using DMA in place of interrupt driven IO. So this is very simple. Sir, how do we define the formula for speed up? Speed up using what? Using DMA over interrupt driven IO. Sir, we know that this is basically with respect to performance. Therefore, we know that performance is inversely proportional to the time. Therefore, speed up DMA over interrupt driven will be time required using interrupt driven, inversely proportional. I hope you understand that. Time required using interrupt divided by time required using DMA. Yes sir, good enough. Sir, how much time is required using interrupt? Sir, using interrupt 3502 cycles are required. 3502 cycles multiplied by cycle time. So let's assume cycle time is same. Let's assume cycle time is same because the same processor is being used. Therefore, cycle time will be same. Apart from that, it will be 12. Sorry, 120. So do you realize it will be 3 point something, so it will be approximately 3.4. I mean 2 3s are, yeah, not exactly 3, it will be, yes, it will be 3.4 something, but obviously up to 1 decimal it will be 3.4. Clear? Clear? Everything is okay? Yes, sir. Let's move to the second question. So this is the question which is involving the concept of interrupt driven IO as well as of DMA. Please try to understand there are two different modes of DMA. One is block transfer mode, another is cycle stealing mode. One more is there, that is transparent mode, but no question can be asked on the transparent modes, please, so don't worry about that. So the two modes of DMA operations which are required, which are important, are block transfer mode and cycle stealing mode. So this question is related to block transfer. Let's try to understand what happens. So in block transfer mode, what will happen, sir? We initialize the DMA controller with a count value. And we'll keep transferring the data until the count value becomes 0. So once the bus is allocated to the DMA controller, it will keep transferring the data using that bus until the count value becomes 0. So the initialization of that count will define that how much data can be transferred in one DMA cycle and one DMA operation. So the size of the data count register, so that is data count register. The size of the data count register of DMA controller is 16 bit. So sir, if the register is of 16 bit, then the maximum value that can be represented using 16 bit will be 2 raised power 16 minus 1. 2 raised power 16 minus 1. Most of the time I don't remember this value. So 64 into 1020, 65535. This will be 65535. Yes, sir. So the maximum value that can be represented using the count register is 65,535. That means once the bus is allocated to the DMA, how many bytes of data can be transferred in one DMA operation? Sir, 65,535 bytes of data can be transferred in one DMA operation. Now the another information is the processor needs to transfer a file. So it's a large file. What is the size of the file? The size of the file is 29,154 kilobytes. So the size of the file, if I define so, this will be very large, I can understand, but anyway, leave it as it is, that 154 kilobyte is the file size. Now you need to transfer this complete file from disk to main memory. Can we transfer the complete file in a single DMA operation? No, sir. In one DMA operation, we can transfer only 60. We can transfer maximum 65,535 bytes of data. Right now, the memory is byte addressable. Okay, so it's fine. If it is not given, by default, I'll assume that the memory is byte addressable. Now it is asking the minimum number of times the DMA controller needs to get the control of the system bus. So once the control is given to the DMA controller, once the control of the system bus is given to the DMA controller, it will be able to transfer only 65,535 bytes of data, right? But the DMA controller needs to transfer this much amount of data from the disk to the memory controller. So it is asking that how many times you will have to initialize the DMA controller. So the number of times we will have to initialize the DMA controller will be, sir, 29,154 into 1024, because it is kilobyte, byte, divide by, in one operation you will be able to transfer 65,535 bytes, right? So those many number of times, it may be in fraction, so it's okay. So 29,154 into 1024 divide by, it comes out as 400, sorry, it comes out as 455.53. So please try to understand, even if the DMA controller get the control of the system bus 455 times, then also some portion of the file will be left in the disk, and to transfer that remaining portion of the disk from that, to transfer that remaining portion of the file from disk to memory, you will have to provide the control of the system bus to the DMA controller for 456th time. So it is asking that the minimum number of times the DMA controller needs to get the control of the system bus from the processor to transfer the file from the disk to main memory will be 456. So why this answer is in terms of minimum? Because it is not necessary that all the time we initialize the value of count to its maximum value. If we initialize the value of count to its maximum value, then also will require the control of the system bus at least 456 times. So in 455 times, in the first 455 times, the value of count will be exactly 65,535. In the last count, in the last round, the value of the count register will be only to transfer the leftover bytes of data of this 29,154 kilobyte file, right? So let's assume if 600 700 bytes are left in the last round, then we will initialize the count value, or we will initialize the count register only by that particular value. Clear? So the correct answer for this will be 456. Please try to understand. I have not included that particular type of question just to restrict myself to the three questions, because we were discussing 24 questions. But remember that, sir, if we are using block transfer mode, then percentage of time for which CPU is blocked. During DMA operation, this is with respect to block transfer mode. This is not relevant with respect to this particular question, but please remember this. The percentage of time for which CPU will be blocked will be given by, sir, when the transfer is being performed, then obviously CPU will be blocked. Transfer time. Plus, please try to understand, we will initialize the DMA. So if that information is not given, that how much time is required to initialize the DMA, we will consider it negligible. But if it is given, then we will consider that also. So plus DMA controller initialization time. So these are the two times when CPU is not performing any useful operation. Divide by transfer time plus preparation time, that the time that is required to prepare the data. Sir, in one go, how much data you are trying to transfer? Sir, we are trying to transfer 65,535 bytes of data. So until you prepare all this 65,535 bytes of data, you will not start the process of transfer, right? So this is the logic with respect to block transfer mode. Plus DMA initialization time. So please remember, there is an extra formula which I am not going to use in any of the three questions which I am about to discuss, but this is an important formula that whenever they ask you the question related to the percentage of time for which CPU will be blocked during the DMA operation while we are using block transfer mode, it will be transfer time divided by transfer time plus preparation time into 100%. Into 100%, that's a separate thing. Into 100%. But it's okay. If DMA controller initialization time is given, then while we are initializing the DMA controller, then also CPU will be blocked, because DMA is busy in initializing the DMA controller. So basically it is not performing any useful operation for the program. So that's one thing. So please remember this particular thing. The formula which we will use for the cycle stealing mode, so this is for block transfer mode, the formula which we will use for the cycle stealing mode, that formula we are going to use in this third question. So consider a computer system with DMA support. So okay, you have a computer which DMA support is available. The DMA module, please try to understand how do you analyze whether the question is of cycle stealing. So sir, the DMA module is transferring one 8-bit character. The DMA module, please look at this. The DMA module is transferring one 8-bit character. Okay, so it is transferring one character in one CPU cycle. It is transferring one character in one CPU cycle From where? Sir, from device, okay, from the disk or the device to memory. From device to memory, that is IO device to memory. Through what? Through cycle stealing at a regular interval. So generally, if it is given that cycle stealing is in the regular interval, means this cycle stealing will keep going, and if cycle stealing keep going, then the percentage of CPU cycles or percentage of memory cycles stolen for the DMA operation will be transfer time divided by preparation time. I am not going to go into the derivation of that particular thing, but please try to understand that if somebody asks you that uh, percentage of CPU cycle stolen or percentage of CPU cycles used for DMA will be transfer time, because when we are transferring the data, the CPU will be utilized, or CPU will be busy, or CPU will be blocked, it will not be performing any useful operation, divided by preparation time. Into 100%. So somebody asked that percentage of CPU cycles used for DMA. So percentage of CPU cycles used for DMA will be transfer time divided by preparation time into 100%. If the percentage of CPU cycle used for DMA in block transfer mode, so this is with respect to cycle stealing. The percentage of CPU cycles used for DMA with respect to block transfer will be transfer time divided by transfer time plus preparation time into 100%. Even if we visualize, even if we think that this DMA initialization time is negligible, then also transfer time divided by transfer time plus preparation time. But with respect to cycle stealing mode, it will be transfer time divided by preparation time into 100%. If the cycle stealing is being done at the regular intervals, it means we will keep stealing the cycles or performing the data transfer operation. If we are transferring only 1 byte of data, if we need to transfer only 1 byte of data using cycle stealing mode, then the percentage of time for which CPU will be blocked will be same as block transfer mode. This will be the case only when we use the cycle stealing mode for a continuous period of time or for infinite period of time. So that's the idea. Now what is given? Sir, consider a 2 megahertz processor. So it is given that processor is of 2 megahertz, therefore time period will be equals to 1 by f. So we know 1 upon 2 megahertz will be nothing but 0.5 microsecond. Yes or no? Megahertz will be 10 to the power 6. So this will be 0.5 microsecond. So cycle time is 0.5 microsecond. Please try to understand, it is given in the question. It is given in the question that 8-bit character can be transferred. DMA module is transferring 8-bit character. So in one cycle stealing, it will transfer one character. It may be 1 byte, it may be 1 word. So in this case, it is 1 byte. So in one cycle stealing, it is transferring 8-bit character, and for that the time required is of 1 CPU cycle. So sir, 1 CPU cycle is of 0.5 microsecond. Therefore, basically the transfer time for 8-bit is of 0.5 microsecond. Please try to understand. This is the actual formula which will be used to solve this question. So transfer time, everything is available. So percentage of CPU cycle used for DMA. In question it is given that if 0.5% of processor cycles are used for the DMA, so it will be percentage of CPU cycles used for the DMA will be 0.5%. Anyway, everything will be clear. So this value is 0.5%. Now the transfer time. In order to transfer 8-bit character, you require 1 CPU cycle, and 1 CPU cycle is of 0.5 nanosecond. Therefore, transfer time will be 1 CPU cycle, and this is actually equals to 0.5 microsecond. But we don't know that how much time will be required to prepare this 8-bit character. So basically divide by preparation time for 8-bit character. Transfer time divided by preparation time for 8-bit character into 100%. Into 100%. That's what we know. This is given. So percentage will be cancelled out. So let's forget about that. Now please try to understand. If we try to solve this equation. Hello, sir, preparation time depends on what? Preparation time depends on the data transfer rate of the device, and that is what is being asked, that what is the data transfer rate of the device, what is the data transfer rate of the IO device. Which device? IO device. So it is asking that at what rate. So until those 8 bits are prepared, you cannot start transferring. So how much time will be required in the preparation of those 8 bits? So preparation time for 8-bit character is what we are trying to calculate. So please try to understand. If I do some calculation, then this 0.5 will be cancelled out. So can I say that preparation time for 8-bit character will be what? So this 0.5 will get cancelled out. So it will become 100 microsecond. Yes or no? Preparation time for 8-bit will be 100 microseconds. Sir, it is asking that how many bits per second can be transferred. How many bits per second can be transferred? So sir, in 100 microseconds, 8-bit can be prepared. In 100 microseconds, 8-bit can be prepared. Therefore, in 1 second. So please, in 100 microsecond, 8 bits can be prepared. Therefore, if I ask you how many bits can be prepared in 1 second, therefore, in 1 second, sir, to convert this into second, you will have to multiply by 10 raised to power 4. So multiply 10 raised to power by 10 raised to power 4 in the LHS, in the RHS. So it will become 1 second in the LHS, in the RHS it will become 80,000 bits can be prepared. So that's the idea. In 1 second, 80,000 bits can be prepared, means the data transfer rate of the device is 80,000 bits per second. How many bits can be transferred from the device in 1 second? Sir, the number of bits that those can be transferred from the device. Please try to understand. This is not. Now you may say, sir, 8-bit character can be transferred from device to memory only in 0.5 microsecond. Yes, 8-bit character can be transferred from device to memory only in 0.5 microsecond once the 8-bit character is ready. Once the 8-bit character is ready. But this data transfer rate of the device, is basically with respect to the data preparation time, that data transfer rate of the IO device. So data preparation time always depends on the data transfer rate of the device. Data transfer time depends on the memory latency of the device. So this 0.5 microsecond is with respect to memory latency. That memory operation is taking 1 clock cycle in order to get 1 8-bit character. Clear? So transfer time will generally depend on, in DMA, using DMA, transfer time will depend on the memory latency and the preparation time will depend on the data transfer rate of the device. So it is asking the data transfer rate of the device. So based on the data transfer rate of the device, we will, the data transfer rate of the device will be with respect to preparation time. And we know that the preparation in 1 second, 80,000 of bits can be prepared. In 1 second, 80,000 bits can be prepared. So if in 1 second, 80,000 bits can be prepared, means the data transfer rate of the disk is 80,000 bits per second. From that particular IO device, the disk that can be transferred in 1 second will be, number of bits which can be transferred in 1 second will be 80,000, not directly. So bees, if we do not use the DMA, then this is the speed of the disk that this is the speed of the IO device, that if you use programmed IO, then in order to transfer 80,000 bits of data, the CPU will be blocked for complete 1 second, Clear? So that's the idea. So the answer for this particular question will be 80,000. So these are the different formulas which you need to remember: percentage of time, percentage of CPU cycles stolen for DMA operation using the cycle stealing mode will be transfer time divided by preparation time. Transfer time depends on the memory latency. Preparation time depends on the data transfer rate of the device, IO device. Clear? Similarly, now percentage of time for which CPU will be blocked using the during the DMA operation. While we are using the block transfer mode, it will be transfer time divided by transfer time plus preparation time into 100% if the DMA initialization time is not given. If DMA initialization time is given, then we will also include the DMA initialization time in the numerator as well as in the denominator, because during the DMA initialization CPU will be blocked. It is not performing any useful operation. Clear? So these are the three questions from the concept of interrupt driven IO and DMA. These similar type of questions will be asked in the GATE exam. Similar type of questions will be asked in the GATE exam. So recently they have asked the questions from this cycle stealing mode of the DMA multiple times, and every time the question is of the similar nature. The question is of the similar nature. So you just need to understand that what transfer time depends on what, preparation time depends on what do I mean by percentage of CPU cycle used for DMA operation, and why this is transfer time divided by preparation time, not transfer time divided by preparation time plus transfer time, because when we are using cycle stealing mode, then when we are using, let me just give you a hint, when we are using cycle stealing mode, then the transfer of 1 byte of data or transfer of nth word of data is overlapping with the preparation of n plus 1th word of the data. So when we are transferring one word from IO device to memory, at the same time IO device is preparing the next word. So when we are transferring one word, the next word is simultaneously being prepared, because we don't need to prepare all the word before we start transferring. In this particular case, if we are using block transfer mode, then we cannot start the process of transferring until all this 65,535 words are prepared. But in this case, as soon as one word is prepared, we can start transferring. And when we are transferring first word, the preparation of the next word can eventually overlap with the transfer of the first word. That's why this will eventually become like this. So that's okay. I mean, this is it. So that will be all for interrupt driven IO and DMA concept. So we have discussed all 24 questions of COA for GATE 2024. On Monday, I'll conduct a mock test in which I'll include 24 questions from the different topic. They are not the GATE questions. So please revise all your concepts and appear for that particular mock test. Definitely you will learn something new. So on Monday, you all will try to give the answer of those questions. It will be a recorded session. On Tuesday, I'll discuss the solutions of those questions. Clear? So one session will be on Monday in which you guys will appear for the mock test, and on Tuesday at same time, that is at 7:30 p.m, I'll discuss the solutions of that particular mock test. So that will be all. If you like the video, then please hit the like button. If you are new to the channel, then subscribe for the channel and press the bell icon to get the notification about our upcoming videos. That will be all for this video. Thank you very much. Thank you for joining. Keep learning and keep prepared. Thank you.